we have given function y and we have to find maximum, minimum and inflection points. So first we find the domain of our y function. We have the power, subtraction, multiplication. So it means the domain for this function is all real numbers. Next, to solve this problem, we will use the second derivative test. So first we need to find first derivative. Y prime is equal, derivative of x to 4 is 4x to third, minus derivative of 2x squared is 2 times 2x. So y prime is equal 4x to third minus 4x. Next, we have to find when our first derivative is equal 0. Y prime is equal 0 if and only if 4x to third minus 4x is equal 0. We have to solve this equation. I will factorize 4x, so in parentheses we will have x squared minus 1 equals 0. Next, when the left side will be 0, when 4x is equal 0 or x squared minus 1 is equal 0. So x is equal 0 and we have x squared equals 1. So x is equal 1 or x is equal negative 1 because negative 1 to second power is 1 and 1 to second power is 1. So we have three critical values. Next, we have to find the second derivative. So the second derivative, it means we have to find the derivative of the first derivative. So y this, it will be derivative of 4x to third is 4 times 3x to second minus derivative of 4x is 4. So y this is equal 12x squared minus 4. Next, when we have second derivative, we have to calculate the second derivative for 0, 1 and negative 1. This is our critical points. So y base of 0 is equal, I have to replace x by 0, so it will be 12 times 0 to second power minus 4, so y base of 0 is equal negative 4. When the second derivative is negative, less than 0, it means we have maximum for x equals 0. So let's calculate this here. X equals 0. So it means we have to replace x by 0 in our function y. Let me copy this function here. We have y equals x to 4 minus 2x squared. So for x equals 0, we will have y of 0 equals 0 to 4 minus 2 times 0 to second power. So we have y of 0 is equal 0. So we have our point 0, 0, and because the second derivative is negative, it means at this point we have maximum. Okay, next we have to calculate second derivative for 1. So y base for 1 is equal, and we just replace, let me underline this, this is our second derivative, x by 1. So will be 12 times 1 to second power minus 4. Y piece of 1 is equal 12 minus 4 is equal 8. 8 is positive number. It means that we will have minimum at this point. Let's calculate this point. We have now x equals 1. So y of 1 will be, this is our function, y. We have to replace now x by 1. So it will be 1 to 4 minus 2 times 1 to second power. So we have y of 1 is equal 1 minus 2. So it's negative 1. So we have 0.1, negative 1. And at this point, we have minimum. Why minimum? Because the second derivative for x equals 1 was positive. Now, we have to check our second derivative for negative 1. So, we have second derivative of negative 1 is equal. Now we replace x by negative 1. So we have 12 times negative 1 to second power minus 4. So y piece of negative 1 is equal 12 times 1 is 12 minus 4 is 8. It means we have minimum again because our second derivative for x equals negative 1 is positive, greater than 0. So we have x equals negative 1 and we have to calculate this point. Y of negative 1 is equal. Now we will replace x by negative 1. So it will be negative 1 to fourth power minus 2 times negative 1 to second power. It means our y of negative 1 is equal 1 minus 2 is negative 1. So we have third point is negative 1, negative 1. And in this point, we have minimum. Why minimum? Because the second derivative for x equals negative 1 is positive. Now we have to find if our function has inflection points. To find inflection points, we need second derivative. We already calculate the second derivative and we have to check when this second derivative is equal 0. So let me copy. Our second derivative is 12x squared minus 4. The second derivative is equal 0 if and only if 12x squared minus 4 is equal 0. So we have to solve quadratic equation. First, I will move negative 4 to the right side, so it will be 12x squared equals 4. I will divide both sides by 12, so it will be x squared is equal 4 divided by 12 is 1 over 3. So we have x is equal square root of 1/3 or x is equal negative square root of 1/3. We have these two values. Now we have to check if in small distance from these 2 points our second derivative change the sign. So to find this, the easiest way in my opinion is to draw graph of second derivative function. So we have quadratic function. The graph will be parabola. Have x. We have roots, negative square root of 1/3 and positive square root of 1/3. Now the parabola is open up because we have positive coefficient before x squared. And we see that for x equals square root of 1/3, we change sign from positive value to negative. Because this part of our graph is above x-axis, so has positive values, and this part is under, so has negative values. And again here we have negative values from the right side of negative square root of 1/3, and on the left side we have positive values because this part is above x-axis. So it means we will have two inflection points. We have x, we have to calculate the y coordinate. So first we will find second coordinate for x equals square root of 1/3. So let me copy this. X equals square root of 1/3. So y of square root of 1/3 is equal. We have to replace x by square root of 1/3. This is our y function. So it will be square root of 1/3 to 4th power minus 2 times square root of 1/3 to 2nd power. So this is equal square root of 1/3 to 4th power. It will be 1/9 minus 2 square root of 1/3 to 2nd power is 1/3. So this is equal 1/9 minus 2/3. To subtract these two fractions, we need denominator will be 9. So we have 1 minus 2 times 3 is 6. So we have negative 5/9. So we have our first inflection point. First coordinate is square root of 1/3. Let me write this, square root of 1/3. And the second coordinate is negative 5/9. This is our first inflection point. Next, we will calculate the second. We have x equals negative square root of 1/3. So y of negative square root of 1/3 will be, we have to replace to our y function x by negative square root of 1/3. So we have negative square root of 1/3 to 4th power minus 2 times, and in parentheses we have negative square root of 1/3 to 2nd power. So this is equal negative sign to 4th power give us positive. Square root of 1/3 to 4th power is 1/9 minus 2 times negative sign to the 2nd power give us positive. Square root to 2nd power will reduce the square root. So we have times 1/3. This is equal 1/9 minus 2/3. This is equal, we calculate area is negative 5/9. So we have our second inflection point. First coordinate is negative square root of 1/3, and the second coordinate is negative 5/9. This is our second inflection point. So we solved this problem.